Good morning, class. We are looking at the types of real numbers. What are the different types of numbers is the essential question. Learning intention. I'm learning to identify different types of numbers. So now is the time to pause the video and see if you can do the warm-up questions on your own and then check your answers. If you're able to do the warm-up questions on your own, then you know you understand the concept. Pause the video now. I hope you tried. So here we go. We're looking for all the x to the third terms. 3 is the largest exponent, and we always start with the largest exponent and go to the smallest. So it's 2x to the third minus x to the third. Okay, now we're going to look at our x squared terms. I've got negative or minus 3x squared. That's the only x squared term I have. Now we go to our x terms. We have plus 5x and plus x. Now, last we end up with our numbers. -3, +8, -3 plus 8. Okay, you're dealing with coefficients only. If it's not there, it's understood to be 1. So 2 minus 1. 2 minus 1 is 1. If it's 1, I don't need to put it there, so we start with x squared. We bring down the -2x squared. 3x squared, sorry about that. -3x squared, because that's the only one there. Then we're looking at 5x plus 1x. I've got 5 here, I add 1 more, and I end up with this total of 6x. And finally, your numbers. -3 plus 8, think about 8 minus 3, and that is 5, and it'll be a +5. So hopefully you were able to get that one done on your own. Now let's look at the next one. You're going to solve using order of operations, and of course the first thing we have to do is distribute, because nothing can be combined inside the parentheses. So we used to all the time use little arrows. Okay, now 2 times x is 2x, plus 2 times 3 is 6. 4 times x is 4x, plus 4x. 4 times -1 is -4, minus 4 equals 20. Hopefully you were able to do that much on your own. So rearranging 2x plus 4x, those are our x terms, plus 6 minus 4 equals 20. Okay, I'm going to pause here, make sure you understand what's going on. Okay, time to deal with the coefficients. 2 plus 4 is 6, so it's 6x, plus 6 minus 4 is +2, equals 20. Okay, now I am ready to finish it up. (6x plus 2 equals 20). When you're getting started, make sure you give yourself the support where you draw the line through the equal sign, draw the line underneath. You're thinking about opposites. 6x plus 2, the last thing I did was add 2. The opposite is to subtract 2. What I do on this side must be done on the other side. So this is 6x, this part's gone, equals 18. 6x means I've done multiplication. The opposite of multiplication is division. And x would equal 3. Okay, now we're getting into the types of real numbers, and you have to know what they are. So real numbers are the first one we're starting with. The symbol for real number is an R with an extra line in it. Real numbers are all numbers that are not complex. Okay, so we'll get into the definition of real numbers more later on, but that's the definition we're going to use for now. Natural numbers, think of when you learn to count. 1, 2, 3, that's your natural numbers. Sometimes they're also called the counting numbers. They are whole numbers greater than 0. Your symbol for natural numbers, big surprise, is an N. The examples are 1, 2, 3, 101, so forth. Okay, the next set we're going to talk about are our integers. The integers are the set of positive and negative counting numbers and 0, or positive and negative natural numbers and 0. Okay, the symbol is a Z. Once again, that middle piece has an extra line. Your examples are -8, 0, 5, 100. In other words, you won't have a fraction. That brings us down to our rational numbers. Okay, rational numbers are real numbers that can be expressed as a ratio. When we talk about ratios, most of the time we are talking about fractions. In other words, a ratio of 2 integers, a fraction of 2 integers. And if it happens to be a decimal, the decimal will terminate or repeat. Okay, the symbol for rational numbers is a Q. I never understood that one. Some examples. 2/5, 0.15, 7, 0.6 with a repeating 6. So if you're looking at the rational numbers, they can be expressed as a fraction. 7 can be expressed as a fraction 7 divided by 1. Here's your repeating decimal. Here's your terminating decimal. Here's your fraction. That brings us to irrational numbers. Irrational numbers are real numbers that are not rational. They cannot be expressed as a ratio. Okay, the symbol is an I. Once again, that middle part has a couple lines there. And an example that most of us are familiar with is pi. That's probably the most well-known irrational number. Some other ones would include the square root of 7, the square root of 2, etc., etc. Okay, what are the only 4 operations we use in math? Addition, we add, we subtract, we multiply and divide. Okay, so now we're going into the closure property. Think of what the word close means. Close means what? If I close the door, what happens? Well, once the door is closed, everything inside the room stays there until it's opened again. So if we think about the word close and what it means, the closure property means that when an operation is performed on elements in a set, that the result you get is also in that set. So we're using the add, subtract, multiply, and divide. Okay, so closure property means that if I do any operation with 2 elements of a set or more, that what I get is also in that same set. The best example is found in the set of integers, because we know what integers are, the counting numbers, their opposites plus 0. So if I'm looking at addition, the set of integers is closed for addition because 2 plus 3 equals 5. 2 is an integer, 3 is an integer, 5 is an integer. So no matter what integers I use, I will still get an integer out. What about subtraction? So if I take 2 minus 3, I end up with -1. 2 is an integer, 3 is an integer, -1 is an integer. So it works for subtraction. What if we multiply? 2 times 3 is 6. Okay, 2 is an integer, 3 is an integer, 6 is an integer. It works when I multiply. What about divide? 2 divided by 3 is 2 over 3. That's a fraction. So is the set of integers closed under each and every one of those operations? No, it is not closed under division. Okay, so as we're looking at all these different numbers, we're going to think down to this smallest set. We start with the bigger and we come down to the smaller. The first thing we work with is what we call the natural numbers or the counting numbers. That's our smallest set. And remember, that is the n. Okay, from there, we start adding to it. When we add 0 plus the negatives, we end up with our set of integers. Integers is that z. Okay, every single natural number is an integer, but all integers are not natural numbers. So you can see this is your bigger set. Within the bigger set, you've got the smaller set. Okay, now we're going to branch out a little bit more. You've got the natural numbers, you've got the integer numbers, and then you've got the numbers that are between two integers. We call those our rational. Remember, we can do those fraction numbers. Rational numbers are symbolized by a Q. Okay, within this whole big set, we have our real numbers. Real numbers is that funny looking R. There's one set that is a subset of the real numbers, but it is not rational. What would it be called? If it is not rational, it is called irrational. And that is your I with that funny looking extra line in here. Okay, so these are the ones we normally work with. As you get into your higher level, we have what we call a complex number. The symbol for complex is a C. Once again, you've got that little extra edge on it. It makes it stand out a little bit. Okay, so the complex number has a rational part and it has an imaginary part. Now the imaginary part is the square root of -1 is equal to I. So as you see, we start with the smallest. We learn to count. Then we add positive and negatives. Then we add our fractions and decimals. Then we add everything else, including pi. Complex and imaginary are some of the last things we learn about. So I know I am successful when I can identify the different types of numbers. And these are the types of numbers.